Welcome everyone to my LeetCode Biweekly Contest 137 livestream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few moments, we'll be doing contests live, we'll be answering questions in the chat, so come and join us every weekend for the contest. No code, no answers will ever be shared during the contest, but immediately after the contest ends, we will go through solutions for all 4 questions, so make sure you stick around. If you enjoy LeetCode content, do check out the rest of my channel. I have videos on different problems as well as the hardest question 4s of previous contests. And as usual, like and subscribe to stay up to date on new videos. Alrighty. Oh, gotta put the screen back on. Okay, so it's Biweekly Contest 137. We have 5 more minutes to kick off. You're back. Welcome everybody. Welcome. Let's see how many people show up for the stream. I generally encourage everybody who's watching the stream to do the contest alongside the rest of us. I always felt that that's the best way to learn. But, after speaking to some of my viewers, I've realized that you can also learn just by watching people do things. It's not ideal. Ideally, if you really want to get good at programming, you should do it yourself. But just by watching other people doing and listening to their thoughts and thinking through the questions on your own, it does help you get better at programming. So that's one thing you could try. Note that we will not give out any answers we don't give out solutions during the stream, but immediately after it ends, we will go through solutions for all 4 questions. So make sure you stick around. And if there are things that you guys want me to go over, or there are like specific tips and tricks, or if there are industry insider information that you want to know, make sure you comment on the videos, let me know, and I can put out new videos that address these things that you guys are interested in. A lot of my videos are just solutions or going through programming examples, and I realize that's not the thing that everybody wants to know about. So let me know what you like, and we'll adjust what the channel presents. So we're 3 more minutes. Yeah, I was actually looking at the daily problem from before. So I'm trying to restart my streak again. I'm back to 2. At one time, I had almost, I think, more than 100 days of daily challenge. And then I missed 1 day. And once I missed 1 day, boom, the whole thing ended. I stopped doing it every day. So I'm trying to restart the daily challenge. Today's daily challenge is actually a really interesting problem. If you haven't looked at it, I highly recommend you do it. It is exactly the kind of question that comes out in a programming contest. It is also exactly the kind of question that may come out in a technical interview. So note that this is medium. Medium questions are the ones that companies are most likely to that companies are most likely to test for. The hard ones tend to be way too difficult in a time-constrained, controlled environment. So, let me see. Yeah. So, this is a pretty classic dynamic programming problem. You haven't realized that already? So, take a look at it. I'm not going to go too much into it because the contest is going to start soon in a few minutes. Please try to do the last one first as soon as possible. I'll try. I'll try catch you up. And welcome to the channel. I don't think I've recognized your name. Wait, do you mean do the last question first during the contest? Or do you mean do the last question when we're going through solutions? So during the contest, I probably have to do things in order because of the way the scoring works. I'll see. Because if I don't get the early questions in sooner, if I just do the last question and I don't get it right, then I might get into trouble with the scoring. Okay, quite a few people are showing up. The contest is almost about to start. So once again, I actually have a different tab that I work on. So you will not see me code live. That's by design because this is, after all, still a contest. We want to have competitive. We want to maintain competitive integrity. We don't want to just give out our answers on stream or anywhere else. It is also a violation of the rules to do that. So I will not be sharing answers during the stream, during the contest. Immediately after it ends, we will go through all of the questions. Hey, Rohan Sharma, good to see you again. I'm always excited to see a familiar face. And for people who are new to this channel, welcome. All right, contest begins. Good luck, everybody. Let's hope nobody DDoSes us today. Find the power of k-size subarrays. You're given an integer of nums of length n and positive integer k. The power of an array. So question 1 and 2 are actually identical, right? I think they're identical except that the size of the inputs. So the size of the inputs are the only difference between 1 and 2. So if you solve 2, you'll solve 1. So maybe it makes sense to solve 2 first. Okay. Okay, interesting. So you need to find the power of all subarrays of size k. So subarrays are contiguous. So in example 1, there are 7 elements in nums and k equals to 3. So the number of subarrays of size k will be the length of the nums minus k plus 1. So 7 minus 3 plus 1, which is 5. Yeah. Okay, that makes sense. Welcome, welcome. I see more people have joined the channel. Just for the people who are new, I actually do my coding on a separate screen because I don't want to share answers during the contest. So if I'm quiet, that's not because nothing is happening. If you ask questions, I will see it and I will answer. So feel free to ask or to talk in chat, ask questions, and I will get to you. Three flips. Yeah, it's a pretty quiet chat. Once again, feel free to ask questions. N minus. So the first question is not that hard, but if you complete the second question, then you can probably get the first one for free. So I would recommend people do that. Hmm. Huh. I'm trying to get fix a bug in number 2. I have a weird off by 1 error. So I'm just doing number 2. I'm skipping number 1. I'm hoping that number 2's answer will translate number 1. So true. Oh, interesting. So 3 and 4 are also the same question, with larger inputs. So we only really have 2 questions today. Is that right? Yeah, that's right. You're given an m by n 2D array board representing a chessboard where board ij represents the value of cell ij. Rooks in the same column attack each other. You need to place 3 rooks such that the rooks do not attack each other. Return maximum sum. Three rooks so that don't attack each other, and return the maximum sum of the cells on which the rooks are placed. Okay. And the board is can be very large. Interesting. This looks like a dynamic programming problem, I think. Let me see. The size of the board can be 500 by 500, so it's a very large board. And so if we if we consider the state of the board, it feels like a dynamic programming problem, but we need some way to remember which rows are taken. Because there are 3 rooks. This is a very quiet chat today. This is a really quiet chat today. So remember, if you have questions, feel free to ask. If you don't ask in the chat, I see a actually I do see a question. I'm sorry, Rohan Sharma. I don't see your question on the YouTube page for some reason. Yeah, can I give hint for question 1? Of course. I'll tell you. Maybe I'll give the hint for question 2 because I didn't try question 1, and question 2 is the same thing. So basically, in question 2, find the power of k size subarrays 2. You're given an array of integer nums of length k and a positive integer of length n and positive integer k. The power of an array is determined as its maximum element if all of its elements are consecutive and sorted in arranging ascending order. Otherwise, it's -1. You define the power of all subarrays of size k. So first of all, let's go through an example. So let's say our array is 1, 2, 3, 4, 3, 2, 5. What are the subarrays in this array? Well, the subarrays are things that are contiguous, right? So we have one subarray here, with another subarray here, 2, 3, and 4, with another subarray here, 3, 4, and 3, with another subarray here, and then we have another subarray. So the number of subarrays, there are 5 subarrays. Subarrays are just contiguous. They have to be side by side in a sequence. So 1, 4, and 5 will not be a subarray. Okay, so the game that we want to play here is we're trying to find, for each subarray, we're to find out what is their power. What's their power is either the largest number, right? It's either what's the number? Yeah, it's either the largest number, or -1 if it's not consecutive. So the first thing we can do is to try and figure out where are the -1s, right? Where are the -1s in this? Well, we know there's a -1 when we break one of the rules. There are 2 rules here. They are consecutive and sorted in ascending order. Okay? They're consecutive and sorted in ascending order. Well, basically it's just one rule, which means that 1, 2, 3, this doesn't break any rule, but 3, 4 doesn't break any rule. 4, 3, this one breaks a rule. This one, this thing right here is bad because it's not sorted in ascending order, it's not consecutive. 4 to 3. It's supposed to go 1, 2, 3, 4. Likewise, this one is also bad. 3 and 2 is bad, and 2 and 5 is also bad. So the way I think about it is, first, let's figure out where all the sort of bad zones are. So this guy is bad. If your subarray contains this guy, this 4, 3 right here, it will not be a good subarray. Okay? So this is bad. So you have to, you basically cancel this one. So once you figure out where all the bads are, you can now identify where the good subarrays are. So the bad subarrays will have -1. The good subarrays will have its maximum elements. Okay? So we know that any subarray that touches these guys are going to be bad. They're going to be -1. So this is all this one is -1, -1, and -1. Okay? So these guys here are going to be good. And so what is the maximum element of this good subarray? Well, since we know it's already sorted in consecutive ascending order, there's one very easy way to find maximum. Just this guy right here. So this is going to be 4, and this is going to be 3. And this is how you get the strategy, right? This is intentionally vague. I'm not going to give you the actual algorithm. You have to figure out the algorithm yourself. But the hint is you have to identify where all the bad places in this array to avoid, and then try and figure out what the good subarrays are. I hope that was helpful. Got 1 but for 2 TLE error. So risk rate, if you got 1 and you got a TLE for 2, then probably what you did is you have some kind of brute force solution. If you use a brute force solution, it will not work if it's ON square. LeetCode is laggy as fuck today. I don't know what's the deal with LeetCode. Sometimes it works, sometimes it's laggy, sometimes it's alright. My solution just won't submit. Yeah. Sorry about that, Luke Markin. It's not fun. All right. Man. Very, very slow. Map in Q2. So I didn't use any fancy data structure. I did, I maybe you can use a fancy data structure. I'm not sure. I just made sure I went through the list only once. So I have a linear times algorithm. So the trick is, again, remember, you can basically go through the list one time and just remember when's the last time you saw a flip. So this flip here, this going from like 4 to 3, that's a violation of the rule, right? Just remember when was the last time you see a rule being violated. Yeah, nice. Good job, Riz Red. If you still don't get it, it's fine. Don't worry about it. I will go through the solutions at the end of the contest. I can't go over it now because that would be unfair. 3 rooks on the chessboard, such that rooks don't attack each other. Oh, actually, it's not that hard. Interesting. Hmm. Solution for 2. Solution, well, I can give you the hint for 2 is what you see on the board right now. So basically the hint is try to go through the array only once. And as you go through the array, try to remember the last time you saw a like a bad pairing, right? So the idea is you want to find all the sub arrays that are in consecutive ascending order. So when you go through the array, you remember the last time you had an element that was not in consecutive ascending order. If the element was that was last not in ascending order was more than k items away, that means you have an ascending order array. So that's the hint. And then using that, you're able to figure out the solution. Hey, Rate Finance. Can't participate live. I guess I'll just look at prompts. Oh no. Oh no. I'm sorry to hear that. Do you know your computer? Yeah, I'll try to flash the question on the screen, so the people who can't participate live will get to be part of the family too. Okay. Yeah, I think I have a very complicated approach for question 4. But I don't know whether it's the right one. Wait, you can't participate if you arrive late? You mean you can't register once it started? Huh, I'm surprised about that. I didn't realize that there was a limit. Huh. That's true. If you don't have enough time, you join and you don't get all the questions right, then yeah, you're gonna lose rating. That's clever. Huh. Question 4 is kind of funky. So question 4, I'm starting to think of this as maybe it's not a DP question after all. It's like is this some kind of memorization question? I wonder. Because you need a way to remember the first where you. So the problem is that 3 rooks. If there's only 2 rooks, it's easy. But since it's 3 rooks, you need to remember when you're placing the 3rd rook, you need to remember the position of the first 2 rooks. So if you sort of think of this as like row by row, you look at every row and you decide, do I want to place a rook here, and if so, where do I want to place the rook? Yeah, if you do that row by row. If it's 2 rooks, it's quite easy, but 3 rooks is tricky. Okay, let me see if I can do this using memorization. So row number. Oh, actually it can be done. Interesting. Oh, interesting. I think I know how to do it. 500. Let me try the first one first. Placing a rook subdivides the grid into more regions. Huh, interesting. It's not really a spatial problem, right? It's not like a space problem. Because you just want the rooks to not be in the same column or row as each other. So you don't actually have to think of it as two-dimensional problem, I think. Divides the grid into more regions. You probably, I guess, at least the way I'm thinking of it is you go through each row, and every row you decide, do you want to put a rook somewhere in the row or not? And then you keep a track of what's the best that you've done so far. Yeah, except the best is not that. Put a rook here. Got answer for question 2. The hint is what you see on the board. So the hint is you want to go through the list only once. You want to do that linearly. You don't want to do like a n square solution. So you go through the list only once, and as you go through the list, because you're looking for sub-arrays whose elements are consecutive and in ascending order, when you go through the list, you look for the last element that was not in consecutive and ascending order. So that's my hints for question 2. Hints for 4th? I don't have the hints for 4th. Sorry. I'm still working on it myself. I can talk about what I'm thinking for question 4. Let me just talk about what I'm thinking. So I don't have the I don't have the hints for it. So basically what I'm thinking is you want the rooks to be on the board, right? I'm currently not thinking of it as a spatial problem. I'm thinking of it as like read as like a linear problem. So I'm going to read in row by row. Every row I decide, do I want to put a rook in the row or not? And if I want to put a rook in the row, where will I put it? And then I'll keep track of like the best I've seen so far. That's my strategy. That's all. That's pretty much as far as I've gotten. Data structure used in question 2. I didn't use any data structures. I just use, I just made sure I went through the list once. So I tend not to think of things in terms of data structure. I tend to think in terms of what do I need. And once I figure out what I need, I will find the right data structure to use, or even invent my own little data structure. So the algorithm comes first. What are you trying to achieve? And then after you figure out what you're trying to achieve, then you think of the data structure. Yeah, Tusha Gakyu. If your solution is getting timeout for question 2, then you're probably doing some kind of n-square algorithm. That's my guess. You should only go through the list once. If you go through the list linearly once, then it should work. I'm not gonna be able to read the chat for a while. I think I know how to do question 4, so I need to spend some time working on it. So apologies if I'm not as observant of the chat. I'm gonna go in and deep dive. I think I got it. Best. Huh. Maybe not. Score. Oh, very nice, Tusha. Good job. Yeah, I'm gonna put the question 2 back on. Yeah. Because the picture for question 4 is not that interesting. Hey, Tachi. Welcome, welcome. Good to see you again. Plus. Best. Alright. Let's see. Third and fourth can be solved with DP. Very nice. Yeah, I'm still working on the third and fourth one. I tried to do both. We'll see how it goes. Yeah, I tried DP, but I don't think I've worked it out quite yet. So, Kartik, did you manage to solve all 4 questions? If you did, that's very nice. Oh, question third and fourth is solved with DP. Oh, I didn't see the question mark. Sorry, Kartik. I I think so. I'm not sure. I'm trying to figure out. So for question 3, I use a heap. Question 4, I don't think it can be solved with heap. I think it's DP, but I don't quite have the DP structure. So I'm solving question 3 first. DFS? Huh, interesting. DFS. Would DFS work? Wouldn't it be like exponential? Four, 15.3. Oh, you got that with heap? I'm using heap also, but I have a bug. I don't think fourth can be done with heap. I don't think so. I'm not sure. Well, I'm trying to finish up third one. I'm pretty sure I got it. I'm using a heap also, and it seems, yeah, it seems correct. 0509. Expected 280. I got a bug somewhere. I just can't find what the bug is. Oh, crap. No easy in this contest. Yeah, definitely no easy. Even question 1 is not easy. Yeah, I can't solve question 3. I got TLE. I got either TLE or... Yeah, this is gonna be a bad contest for me. Dang it. Huh. Definitely no easy in this contest. I still feel like there's some DP solution for 3 and 4. I just can't figure out what the DP is. Is it really like, is the DP like a 100 by 100 array? And then, so the first two rooks, one way I'm thinking of how the DP might work. So one way I'm thinking of how the DP might work is if there's a 100 by 100 array for the position of the first two rook 1 and rook 2. But then that's going to be super slow because, you know, when you want to place the third rook, you have to find. Yeah, that's going to be super slow. There's got to be a faster way to do this. Yeah, I'm kind of stumped. Yeah, feels bad, man. Hey, Fury Nick, welcome back. So can second be solved directly through sliding window? I don't know if it's a sliding window per se. It's kind of like a sliding window, I guess. You don't need any fancy data structures, I'll tell you that. I'll go over the answer for question 2 once the contest finish in about 10 minutes. So hold on tight. As usual, we don't give out solutions. We don't share code on this channel while the contest is running. After the contest ends, then we can do whatever. Because it's still competitive integrity. Even though I'm sure none of us are competing in the leaderboards. I'm certainly not competing in the leaderboards. If you are, you're probably not. You're not gonna be here. But you know, just to be fair to everybody, we're not sharing answers during the competition. After the contest ends, then we can do whatever. Huh. Yeah, I can't figure out what it is. We can do some kind of depth first search, but the depth first search is going to be... It's going to be exponential time. So that's not great. Let me see. The other way I'm thinking about it is if there's a way Yeah, not super sure. This is tough. Let me see. The problem is there are two rooks. If there's one rook, it's so much simpler. One rook is three rooks. Two rooks is much simpler. Two rooks would be really easy. What's the You don't have to place a rook every turn. You can have one rook or no rook in each row. Even though the input examples all have 3 rows, there can be multiple. There can be a lot of rows, and the rooks can be anywhere. So let's see. Let's say if I have a DP, right? Yeah, the problem is the DP will be 2-dimensional. And then it's going to be very slow because you have to go through every single row. Unless the rows are sorted somehow. Oh, interesting. Can there be some kind of heap? But even the heap is not going to play very well because the heap doesn't work out well. Oh, hey, let me think about it. So every row, okay. Okay, how about like this? We have a DP. And every cell, we say if rook 1 was in this column, and we remember the top 2 values of rook 2. Oh, interesting. So we don't need a large DP. We need a okay. Actually, I think I know. I have a plan. I think I have a plan. Okay, let me see. How would the data structure? Oh, I don't have time to the third and fourth comments. I didn't get third and fourth. I think I have a strategy for third and fourth. I think that might work. But I obviously don't have enough time to code it. So here's what I'm thinking. We keep a data structure. Let's call it like DP or whatever. It's not actually DP, but so the data structure tells you where the location of the first rook is. Okay, Okay, I think I have an idea. So basically the idea is we want to place a rook. We have a data structure, keep track where we place our first rook. And we go through each row. So as we do this, we then rank the top 3 choices for our second rook. So basically, let's say in the first row, let's see how do I describe this well. Okay, I'm thinking of having a data structure. Inside the data structure, we keep track of the rook 1 is at 0. If rook 1 was placed at column 0, somewhere along column 0, that means that rook 2 and 3 cannot be column 0. Then we figure out what are the best possible locations for rook 2. And we only need two possible locations for rook 2. So for instance, in this case, yeah, I think let me crystallize this a little bit more before I put it into words. So for instance, in this case, if rook 1 was on column 1, on column 0, then our best score is going to be -3, and rook 2 will be at our best score. Let's say if rook 1 is here, then rook 2 can be here or here. So our best score is going to be -2 with rook 2 at position 1, or -2 with rook 2 at position 1, 2, 3. Or -3 without rook 2. And then now we go on to column 1. If rook 1 is here, rook 1 equals 1, then our best possible positions for rook 2 will be either here, the score will be 2. Rook 2 is at 0, 1, 2, 3. We cannot use this square because it was already taken by rook 1. So my next best option is -3. -3 plus 1 is -2. And rook 2 is at position 0. Oh, you actually need a few of these. Oh, actually no, you just need... Yeah, you just need 2 of these, yeah. Or, my score will be 1, and there's no rook 2. Now, what happens when I place rook 1 at here? If rook 1 is here, rook 1 equals to 1. My best scores are to put rook 2 here or here. So, if rook 2 is here, 1 and 1 will be 2. My score is 2. And rook 2 is at position index 1. 2 at position index 3. Or my score remains 1 and there's no rook 2. Oh, interesting. So I can keep a data structure that looks like this. And I go down, right? And I go down. And I go down the list. Yeah. And then there's the last one if there's no rook 1. The last option is rook 1 equals to x. So we don't place rook 1. The best place for rook 2 will be equals to here. for 1 point, and here for one at column 3 for 1 point. Oh, interesting. And then we keep updating. And then this way we keep updating. So we pick the best possible. Oh, interesting. I think this might actually work. This might actually work. The 3 highest columns. Yeah, for each row we find the 3 highest columns. Yeah. Yep, that's correct. Yeah. So you don't actually need. Yeah. You don't actually need the whole array. You just need the 3 highest columns. Yeah. I think you're right. Well, the contest is over. Thanks for hanging out, guys and girls. Sorry, I don't want to be discriminatory. Let me get a sip of water, and I'm going to go through question 1 and 2. Question 3 and 4, I think as Danush, you are on the right track. You just find the highest column. Yeah. I think you're very much on the right track. Yeah, damn it. Okay, let me get a sip of water. I'll come back, and then we will go through solutions. No, question 3 has nothing to do with 8 queens problem. It's not related. Yeah, don't think of them as rooks. Think of them as, how do I say? Think of them as making sure you don't. Think of it as selecting 3 different columns and in 3 different rows. Don't think of them as rooks per se. It has nothing to do with queens. It's not spatial so much as it is like row by row. So you shouldn't look at the board as a 2-dimensional geographical space. Yeah, and I think S. Danush is right. You only need to find the 3 highest column. Yeah. Okay. All right. Let's go through the answers. Yeah, this is not a good contest for me. Alright, we are discussing solutions for LeetCode Biweekly Contest 137. Jump to specific questions using the timestamps in the video description. And please check out the rest of my channel if you enjoy LeetCode content. Come join us for programming contests every weekend. I will stream the biweekly if there's a biweekly. If not, I'll stream the weekly. Like and subscribe to stay up to date on new videos. So once again, if you enjoy my content, definitely throw me a like and subscribe. Watching is great. If you can comment on the stream video, just say what you liked about it, or just type in the stream comments whether how many questions you managed to solve. That helps me out a lot. So hopefully you can do that. With that, let us jump to the solutions. Okay, so question 1 and question 2 are actually the same. Question 1 and 2 are actually the same. The only difference is the size of the input. So question 1, the size of input is 500. And then in question 2, the size of the input is 10 to the power 5. So question 1, you can still do it by brute force. Question 2, you're going to have a linear time solution. I'm going to go through just the linear time solution. And that same solution will work for both 1 and 2. Alright, let's go through the question first. Find the power of k-size subarrays 2. You're given an array of integer nums of length n and a positive integer k. The power of an array is defined as the following. Its maximum element if all of its elements are consecutive and sorted in ascending order. So this means 1, 2, 3, 3, 4, 5, 7, 8, 9, so on and so forth. Otherwise, it's minus 1. And your job is to find the power of all subarrays of nums of size k. So, to do an example, 1, 2, 3, 4, 1, 2, 3, 4, 3, 2, 5. Okay, let's say this example. Okay, what are the subarrays? Subarrays, as you recall, are contiguous. So they are connected. So 1, 2, 3 is a subarray. 2, 3, 4 is a subarray. 3, 4, 3 is a subarray. 4, 2, and so on and so forth. These are all subarrays. Okay? So your job is to find subarrays that are consecutive and sorted in ascending order. Which ones are these? 1, 2, 3. That works. 2, 3, 4. That also works. 3, 4, 3 does not work. 3, 4 works. But 4, 3, this needs to be a 5. For 3, 4, 3 to work, this has to be 3, 4, 5. Likewise, 4, 3, 2 doesn't work. 3, 2, 5 doesn't work. So these guys are all minus 1. Okay? And these guys, they're not minus 1. They are consecutive and sorted in ascending order. These two subarrays, their power is their maximum element. Since they are consecutive and sorted, the maximum element is simply the last element. So this will be 3. And this guy will be 4. So your answer here is 3, 4, minus 1, minus 1, minus 1. Right here. Okay. How do you do this? If you want a simple strategy, I think in question 1, what you end up doing is you just have a for loop. You loop over the whole n, and then you loop over k, right? So you have a nested for loop. This will not work for question 2 because question 2, the inputs are extremely large. So your for loop is going to give you n squared, and that will not work. Instead, what you need to do is you want to find a way to go through this array only once. Well, how do you do that? How do you do that? So the thing you want to notice is that when you know that this, for instance, if you know that this is a good subarray, it's consecutive and in ascending order, all you need to do is to check the last pair in order to find out if this is a good subarray, right? So you don't have to check the whole thing again. You just have to check the additional one. In fact, a more precise method will be to check the last time you have two elements that are not consecutive and sorted in ascending order. So this 4 and 3 is bad, right? Because 3 is not 1 greater than 4. If this is bad, it means that everybody after him, up to k, is bad. Okay? So that's what this means. So essentially what you have to do, the way I did it, just show the way I did it, is the first thing I do, I find out all the places that were bad. See, you can arrange this properly. Oh, I can't do that. Damn it. So the first thing I did is to find out all the parts of the array that were bad, that were like flipped around. So all these things, this 4 and 3, 3 and 2, okay? And then what I did is I did a pass over the array, and I check is if the last flip is larger than equal to k minus 1 distance away. So for instance, when I'm like here, when I'm here, let's say it was something like 2, 1, 2, 3, 4. Okay, the last time you had a flip, last time there was a pair of elements that were not consecutive and in ascending order. If that's more than k units away, so let's say my k is 3, okay, this means that this guy is going to be 3. If it's less than k units away, this guy will be going to be minus 1. And then this guy is going to be 4. So long as it's more than k units away from the last time there were 2 elements that were not consecutive and sorted in ascending order. So you find out the last time, the last flip. This is the last flip, the last time that was flipped around. The last time, if it's more than k distance away, then your subarray's power is going to be its maximum. If not, it's going to be minus 1. So that's basically all there is to it. You do it this way, you guarantee that you only go through the array once in one pass, and you will have a linear time solution, and that will pass both question 1 and question 2. Let me just look at the chat real quick. I don't know who, you know who Larry NY is. Yeah, Larry NY. That's a good call out. I might check out his channel. Yeah. So love Markin. Sometimes you think it's before, sometimes you think it's after. You want to do a weekly contest one, they're consistently easier. The weekly contests are easier than the bi-weekly, I think. I do agree with that statement. Yeah. Alright. So that covers both question 1 and 2. Question 3, I didn't manage to do it. But I'll talk a little bit about what I tried and what I think the correct solution might be. So question 3, maximum value sum by placing 3 rooks. You're given m by n 2D array representing a chessboard, where board ij represents the value of cell ij. Rooks in the same row or column attack each other. You need to place 3 rooks on chessboard such that rooks do not attack each other. So I think the conceptualization of this as a chessboard is a bit of a misnomer. So I don't think of it as a chessboard. I think of it as picking 3 unique columns and 3 unique rows. So I think of it as picking 3 unique columns and 3 unique rows. I don't think of this as like a spatial sort of map or battleground or sort of geographical spatial area. That's not how I think about it. I think it's just you need to go through all the rows, pick 3 rows, and out of these 3 rows, pick 3 columns for each of the rows. The rows and columns must all be different, and you need to have the largest sum. That's what you're looking for. It's not so much a spatial problem. That one is a bit of a red herring. I tried a few things. I tried using DP. I tried thinking of this as row and, doing something in the row. I think if there were only 2 rooks, it's much easier. For 2 rooks, you just have to keep track where the first rook is, and then the second rook just finds, the sort of best answer based on where the first rook is. For 3 rooks, it's going to be much harder. So that's the part that I was personally stuck at. I think someone made a comment. Let me make sure I attribute it to the right person. So S. Danush made a comment that says, actually, for each row, we only have to keep track of the 3 highest numbers. That's true. That's true. Because we only have to keep track of the 3 best numbers. If I'm going to place a rook on this row, if I can place on the first one, if it's taken by a different rook, then I have to be able to place it on the second one. If I can't place it on the second one, I have to place it on the third one. The worst I can do is the third highest number in each row. So essentially, I only need the 3 highest numbers in each row. 3 highest numbers in each row. I don't actually need what you call it. I don't actually need all the numbers in every row. So if that's the way to do it, then I think we actually have a strategy. And I think maybe you can even do it by brute force. So I think, and I haven't thought this through yet, but I think what we want to do is for each row pick the 3 best numbers. So for instance, we're in row 1. So again, we want to look at this as a series of rows, right? We don't want to look at this as like a 2-dimensional spatial chessboard. So for row 1 is -3, 1, 1, 1. My top 3 are going to be 1 at index 0, 1 at index 1, 1, this one at index 2, and 1 at index 3. Okay, now I move on to row 2. Yeah, I wonder if you can just do a brute force. You might be able to do brute force, just solve everything by brute force, because there are only 3 columns. So for second one, my best will be 1 in index 0, 1. My second best is this 1 here at index 3. And then my third best is actually -3 at index 0. So basically, what this means, if these 2 are already taken, then I have to fall back on this one. Yeah. Yeah, I think if you do it this way, then you can basically keep a heap. If you do it this way, you can do a heap. Yeah, you can find the... Oh, interesting. You can do a heap if you do it this way. Because then you can say, oh, in row 1, you know, the 3 best are like this. Then my options are... Yeah. Then my options are, if I want to place a rook and in column 1, I have this, a rook in column 2, rook in column 3, so on and so forth. Yeah, I think you can, if we do it this way, we can keep a heap. So what would the heap look like? I think the heap will just keep track of the best possible solutions we have so far. Yeah. So in row 1, we have the 3 best squares for the first rook. Then we can say one solution would be to place a rook in position 1, and our score will be 1. We can place a rook in position 2. Our score will be also 1. And so on. And then when we come to row 2, we can say, hey, maybe we can place a rook in position 1. Our score will be 2, and it will use this and this. So our first rook will be in column 1, and our second rook will be in column 2. Sorry. First rook will be column 2, second rook will be column 1. So this guy and this guy, you cannot pick this guy and this guy because their column is the same. Yeah, so you can actually do it this way. So you can build a heap, and I think this would actually work. Yeah. Yeah, you basically brute force all combinations of 3 rows. You actually, it's actually quite quite a lot better than brute force, because you just need a heap, and the heap guarantees that you only have to look for the top 4 elements of the heap. You don't. It's not even 27 times n to power of 3. You just keep the sort of 4 best contenders. Yeah. So I think that's the only thing that's the main part that I was missing. I did a heap. Let me see if I can show my solution. I did a heap, so the heap works, but because of the way the heap, I have to keep a lot of elements on the heap, I have to use a very large number. So at every step, I have to check all the way down the heap. The reason is because the heap that I built basically has the score plus where the other 2 rooks were placed when I add the 3rd rook. So the problem with this is that when the first rook is like column 1, and then the second rook can be column 1, can be 2, 3, 4. So the sort of size of the heap that I have to explore is going to be very large. Yeah. So this means that I get a timeout, or I get the wrong answer when the size is sufficiently large. But I think if I modify this so that instead of going over the whole row, I just get the top 3, then this should work. Yeah. Well, it's unfortunate. It's so much easier when you've seen the answer. Alright, so I think this is the end of the stream, because question 1 and 2 are the same, question 3 and 4 are the same. Let me see if there are any other questions in the chat. Yeah. Alright. So I think we are done. So thanks a lot, folks, for sticking it out. Thanks for the stream. No problem, Red Finance. Yeah, if you want to help out, make sure you comment on the stream, the video. Just write a comment and says, oh, how many questions you solve, or what's easy, what's hard. It helps me out a lot. Like and subscribe if you haven't already, but I bet most of you are. Once again, thanks for coming. I will be more consistent moving on. I will probably stream every week like I used to before the summer. So yeah. Thanks a lot for coming out week after week. I'll see you guys next week. Bye.